Hello everybody, today we're going to be taking a look at a new AI example. The other day we went over linear regression. However, today we are going to be taking a look at one of the other most popular, fundamental, simple machine learning models, and this is going to be called logistic regression. So, the dataset we are going to be using this time is a little bit different. So if you recollect, last time we went over a dataset where we had a series of students and we created a predictive model to determine the hours studied and their specific exam score. However, this time, using logistic regression, we simply want to know a simple yes or no answer. Would they pass or would they not pass? Would they pass the test or would they not pass the test? And we need a way to calculate this. And let's just start by taking a look at what a graph like this would look like. So we have a series of hours studied and passed. So 0 meaning not passed and 1 meaning passed, right? And we can see the general trend already that the more you study, the more likely you are to pass. That being said, we want to actually quantify this into an actual result that we can predict. We could simply say that, oh yeah, if you study for at least 5 hours, you're guaranteed to pass. However, this isn't a realistic assumption, so we want to find a model that is capable of making an accurate assessment. So what we can do is, first, let's make our data frame. df is equal to pd dot data frame. Data. We're going to make our x and y axis just like last time. The feature is going to be df, and we're going to be a list hours studied. Hours underscored studied. And y, our dependent variable, our label, is going to be df of passed. And let's get a look at creating the model. We can create the model using the x label and the y label. So x label we'll set to hours studied, of course. plt dot y label of passed slash failed. We should also include like 0 to just identify passed as 1, failed as 0. We could do this. Something like this, and then of course this is going to be a scatter plot. plt dot scatter of df of hours studied. Oops. Comma df of paused. Oops. Not paused, passed. Why did I say paused? Passed. Alright, so we created a scatter plot using the x and y feature and labels that we've created, and we've labeled them accurately. We could also just title it something. plt.title of we'll just call it a logistic regression example. Usually I'd say x versus y, but in this case it's y versus x, but in this case it's probably more apt to just show you guys what it is, to indicate that this is an example of us demonstrating logistic regression. So we can run the code, and hopefully, did it save? Let's try again. There seems to be, okay, there it is. It was just taking a little bit. Okay, so we have this example shown up here, and we can see on the graph that we can see all our points are plotted. We have 4 points below here and 4 points up all the way here, because there is a 0 to 1 scale, but none of the ones in the middle are being used at all. We can see that. However, now it comes in a little bit of an issue where we remember what we did last time to create a predictive model determining how the hours studied. For example, 4.5, we could estimate that 4.5 would be somewhere in the middle, but like that doesn't really make sense. 4.5, it could go either 1 or it could go 0. What about exactly 4.99? Does 4.99 equivalent if you study 4.75? What is going to go on in the middle here? Like, you can't use a linear expression because that doesn't seem right to just encapsulate all these 4 points within a single line. So here, what we want to do is we want to use a logistic regression curve, a curve that will somehow fit all of these points in a reasonable way to determine between two binary options, right? So using this, we already imported the logistic regression model. We'll take a look at how we can use this logistic regression model. So let's create our model just by saying, we'll work up here. Model equals to logistic regression. Sorry, it took a bit time to think there. And then we are going to fit it to fit using x comma y, our two data frames that we created for our feature and labels. And now the model should automatically train off of this thing and should create the proper curve to basically identify whether or not this thing is a is like essentially using it should create the curve that will identify um, sorry, my brain is kind of farting right now. We are creating a model that is most indicative of encapsulating the closest possible curve that could showcase all the fit that's in the thing. So how are we going to take a look at this score? Now using plt.plot, we can simply plot the line by saying x. So we are taking, once again, the hours studied as the result, but instead we are going to be using model.predict. Model.predict based off of x. And now let's take a look at what our graph will look like. And you can see that already the graph somehow is able to use logistic regression and basically correlate a way where it finds out that, okay, it connects all these things in between, and although it's not a curve, it can see that like in between somewhere, in between 4 and 5, for example, it'll notice that like there is like some it goes linearly between 4 to 5 hours, but every single point besides that is like not exactly it's not linear because it isn't a linear thing. And yeah, so this is how it is. And once again, we can see the specific values that this predictive model shows. Let's say, for example, we want to predict based off of a score of hours studied being 5.5, or 4.5. Let's say 4.5, right? What would it be? Would it be a pass or a fail? So what we can do is we can say prediction is equal to model.predict, and we could say 4.5, for example. And we could say, sorry, it's supposed to take this as a list of a list. And we can also find the specific probability, because we know that it's not guaranteed. So probability is equal to model dot predict proba of 4.5. And now we could simply print, let's say, prediction, and then we'll say comma prediction of 0, because we want the first result in the prediction list. And we can also predict, oh shoot, sorry, what am I saying, print the probability by, we can say probability of, let's say passing first, passing. And to do this, what we want is, we want probability in that probability list that we create here. What it indicates as, it'll be a list of the 0th thing and the first one, because we're trying to find the probability of 1, what it is that it'll pass, right? Sorry, let me just do comma here. Did I do a comma here, or is that a period? That's a period for some reason. And there we go. So we should be able to run this code. Oh, sorry, let me rerun this. Also, when I close this, okay, and there we go, we got the print. So for example, with the model of 4.5, we can predict, it gives a prediction of 0, but it also gives the probability of passing. And in this case, it is 0.49999731092388847. In reality, it would probably be closer to 50% because it's exactly in between 4.5 and 5. But in this case, the model, likely due to an integer error, it determined that the probability of passing is just slightly below 50% if you study for 4.5 hours. And you could test this with various different results, but it will always give the same thing as according to the graph earlier. So that's it for today. Hopefully you guys understood how logistic regression works to basically determine and work with the pass or fail or binary use case, where you're not trying to exactly predict the trend in a data that's in a linear fashion, but basically predicting a yes or no outcome, or a 0 or 1 outcome, a binary result. And understanding how logistic regression is particularly useful for that compared to linear regression. So hopefully you guys gained something from today's video, and I'll see you guys the next time. Thank you.